All right, Algebra 1, lesson 4.8, the last lesson for chapter 4. Okay, it is on functions and relations. Okay, so in the lessons prior to this, we've seen that for every input, so every x, there is exactly one y. Okay, this is a true statement for all linear equations. However, there are some times when this is not true, like for x equals y squared. Okay. A rule like this is called a relation. Okay. Within this relation, meaning you getting any set of ordered pairs, okay? You can have a function. This is a specific type of relation. Where, like the linear equations, every input has exactly one output value. Okay? When you have a function, you can have a domain and you can have a range. So a domain of a function is all input values, or all x values. The range is a set of all values for y, or all output values. Okay, so functions, each x goes to exactly one y. All of those x's are your domain, and all of the y's are your range. So if this is my rule where these are the input going to the output values. Okay, so we have 4, 6, 8 as your input, 0, 1, 4 as your output. If I put 4 in, I get 0 out. If I put 4 in, I get 1 out. If I put 6 in, I get 4 out. And if I put 8 in, I get 4 out. We don't know what the rule is. We just know that these inputs map onto these output values. Looking at this relationship, we're going to say this is not a function. Since the input of 4, right, that's one input, but it has 2 different outputs. Okay. Okay, it's another relationship. These are our inputs, these are our outputs. So I look, 1 maps to 2, 3 goes in, 4 comes out, 5 goes in, 4 comes out, 7 goes in, and 6 comes out. This is a function since each input has exactly one output. Right? It doesn't matter that these two input values give you the same output value. All that you need for a function is that one number goes in, one number comes out. Okay? So this is a function. So then I can say, well, I can have my domain, right? Domain is all input values. So we get 1, 3, 5, and 7. And then there's a range is all output values. So 2, 4, and 6 would be our range. One other way you can use to decide if you have a function is called the vertical line test. And this works on a graph. So what it says is that any vertical line placed on your graph will pass through only one point. Okay, so you have your graph, vertical lines only touching the graph in one place at any given time. So here's a graph, here's a graph, here's another one, and a third. We want to decide if these are functions. So looking here, if I start with any vertical line, this pen is touching that first graph in one place at any given time. So this is a function. Okay, same thing here. Any vertical line is touching the graph in only one place at any given time. So this is a function. On this one, right here, there's a vertical line. It's touching your graph in two places, so it's not a function. And then the last one, right? If I put a vertical line right here, it's touching your graph in 1, 2, 3 places. So this is also not a function. When you have a function and you want to write an equation in function notation, replace your y with this. It looks like f open parentheses x close parentheses. You can read this two different ways. You can say the value of f at x, or we can say f of x. It just means that it's a function that depends on x. Okay, so the x values inside the parentheses, it's telling you you have a function, and it's telling you what the function is equal to at this given value of x. It is not f times x. This is a big one. A lot of people always think it's times x, so they end up dividing. It is not. It is saying you have a function dependent on x, and then it gives you your x value. Okay? So we can evaluate functions at a given value. So it says that the function at x is equal to 7 minus 3x. We want to evaluate it at x equals 4, or when x equals 4. So what you do is anywhere you see an x, you replace it with 4. So f of 4 equals 7 minus 3 times 4. So again, this means the function at 4 is equal to 7 minus 12. So the function at 4 is equal to -5. Another way you can think of this is this gets replaced with y. So this gives us an ordered pair. X is 4, y is -5. Okay, do not divide by f, or do not divide by 4. F is not a variable. It is saying you have a function. So f of x equals 10x plus 3 when x is -2. So f of -2 equals 10 times -2 plus 3. So the function at -2 equals -20 plus 3. Function at -2 equals -17. This is your answer. Do not divide by -2. Okay? F is not a variable in this case. It's saying it's a function. Again, you could determine an ordered pair to say that on this graph, -2, -17 is a point on it. Okay, so that is 4.8. Look for your chapter 4 test as well.